The United States Air Force recently completed a significant milestone in modern aerial warfare by successfully conducting a test where pilots flying F-15E Strike Eagle and F-16C Fighting Falcon fighter jets remotely controlled XQ-58A Valkyrie drones during a simulated air-to-air combat exercise. This event marks a crucial step in the evolving concept of manned-unmanned teaming, where traditional manned aircraft work closely with unmanned systems to maximize combat capabilities while minimizing risks to human pilots. The XQ-58A Valkyrie is a cutting-edge unmanned combat aerial vehicle developed by Kratos Defense and Security Solutions. Designed with an emphasis on affordability, stealth, and operational flexibility, the Valkyrie is capable of long-range missions, flying over 3,000 nautical miles at speeds approaching Mach 0.85 and reaching altitudes up to 45,000 feet. Its stealth features, including a trapezoidal fuselage, swept wings, and a V-shaped tail, reduce its radar and infrared signatures, enabling it to operate effectively in contested and high-threat environments. This makes the Valkyrie well-suited for missions in areas protected by advanced enemy air defense systems, such as those developed by near-peer adversaries like China and Russia. One of the key advantages of the Valkyrie is its cost-effectiveness. While advanced manned fighters like the F-35 can cost upwards of $80 million per unit, the Valkyrie is built to be attreatable, with a price estimated between $2 million and $6.5 million depending on production scale. This affordability allows the Air Force to deploy these drones in larger numbers without the prohibitive costs associated with losing expensive manned aircraft. Additionally, the Valkyrie's ability to be launched using rocket-assisted takeoff and recovered by parachute means it can operate from austere locations, including remote forward bases or maritime platforms, reducing dependence on vulnerable airfields. During the test at Eglin Air Force Base, the F-15E and F-16C pilots utilized encrypted tactical data links, such as Link 16, to directly command the Valkyrie drones in real time. This capability transforms manned fighters into airborne command centers that can coordinate and control unmanned assets as if they were part of their own flight. The drones operated as loyal wingmen, taking on high-risk tasks such as scouting enemy positions, identifying targets, and potentially engaging with air-to-air munitions under pilot supervision. By controlling drones from their cockpits, pilots can keep their aircraft outside the effective range of enemy air defenses while leveraging the drone's stealth and agility to conduct dangerous missions. This test highlights the Air Force's strategic push to integrate legacy aircraft with next-generation unmanned systems, extending the operational relevance of aging platforms like the F-15 and F-16 through advanced technology upgrades. By enabling these fighters to manage unmanned wingmen, the Air Force enhances overall force multiplication, operational flexibility, and survivability. The implications of this advancement extend to the broader command and control structure of air operations. Traditionally, systems like AWACS and ground-based controllers have played central roles in directing air missions. However, manned fighters controlling drones directly can reduce the reliance on these external command nodes, allowing faster decision-making and more responsive tactical control in dynamic combat environments. This shift could lead to new operational doctrines emphasizing distributed command, networked warfare, and autonomous or semi-autonomous unmanned platforms working in concert with human pilots. Looking ahead, the Valkyrie's open architecture and modular design allow it to rapidly incorporate new sensors, weapons, and artificial intelligence algorithms. This adaptability is critical for maintaining a technological edge as adversaries develop increasingly sophisticated air defense systems and unmanned platforms. The Air Force's broader initiatives, such as the Next Generation Air Dominance (NGAD) program and the Skyborg program, aim to field advanced combat aircraft, both manned and unmanned, that operate as integrated teams. These programs envision future fighters acting as quarterbacks managing multiple drone assets in complex multi-domain operations across air, space, and cyberspace. Geopolitically, the deployment of low-cost, stealthy unmanned combat drones like the Valkyrie enhances the U.S. military's ability to project power in contested regions such as the Indo-Pacific. The capability to operate swarms of drones alongside manned fighters offers a strategic deterrent against adversaries seeking to challenge U.S. air superiority. By preserving expensive manned platforms for critical missions and using drones for reconnaissance, electronic warfare, and strike tasks in heavily defended zones, the U.S. maintains operational resilience and tactical advantage. The successful integration of F-15 and F-16 pilots controlling XQ-58A Valkyrie drones represents a transformative development in aerial warfare. It demonstrates the U.S. Air Force's commitment to leveraging affordable, scalable unmanned systems to enhance combat effectiveness, reduce risk to pilots, and maintain superiority against rapidly evolving threats. This advancement not only extends the life and capability of existing manned aircraft but also sets the stage for a future force structure centered around manned-unmanned teaming and networked operations, ensuring continued U.S. dominance in the skies for decades to come.